Hello everyone, today we are going to learn about analytic functions. Derivatives. If a function fz is a single valued in a domain D, then the derivative of fz at z is equal to a is denoted by f dash a and is defined as f dash of a is equal to limit h tends to 0 f of a plus h minus f of a by h, provided that the limit exists and is independent of the path along which h tends to 0. In this case, we also say that fz is differentiable at z is equal to a. Remark: every differentiable function is continuous, but converse need not be true. That is, continuous function need not be differentiable. Analytic function. Consider a single valued function fz in a domain D. The function fz is said to be analytic at a point z is equal to a if there exists a neighborhood modulus of z minus a is less than delta at all points of which f dash z exists. If f dash z exists at every point of a domain D except at a finite number of exceptional points, then fz is said to be analytic in D. These exceptional points are called singular points or singularities of the function. If f dash z exists at every point of D, then we say that fz is regular in D. The terms regular and holomorphic are also sometimes used as synonyms for analytic. Singular point. A point z is equal to z naught is said to be a singular point of a function fz if f dash z0 or f dash z naught does not exist. Cauchy-Riemann equations or Cauchy-Riemann conditions. A necessary condition that w is equal to f of z is equal to u of xy plus I v xy be analytic in a domain D is that u and v satisfy Cauchy-Riemann equations. Del u by del x is equal to del v by del y, del u by del y is equal to minus of del v by del x. That is, ux is equal to vy and uy is equal to minus of vx at every point of D. If these partial derivatives are also continuous, then Cauchy-Riemann equations are sufficient conditions for fz to be analytic in D. Conjugate function. If fz is equal to uxy plus ivxy is analytic, and if u and v satisfy Laplace's equation del to u is equal to 0, del to v is equal to 0, then u and v are called conjugate harmonic functions or conjugate functions. A harmonic function. A function u of xy is called harmonic function if first and second order partial derivatives of u are continuous and u satisfies Laplace equation del to u is equal to 0. Necessary condition for fz to be analytic. Theorem. If fz is equal to u plus iv is analytic in a domain D, then u v satisfy the equations del u by del x is equal to del v by del y, del u by del y is equal to minus of del v by del x, or ux is equal to vy, uy is equal to minus of vx, provided that the four derivatives ux, uy, vx, vy exist, or derive Cauchy-Riemann conditions. Proof. Let w is equal to f of z is equal to u plus iv be analytic in a domain D. Then dw by dz exists. Show that dw by dz has the same value along every path. Let z is equal to x plus iy. Then along x-axis z is equal to x, because in this case y is equal to 0. So del z is equal to del x. dw by dz is equal to limit delta z tends to 0, delta w by delta z is equal to limit delta x tends to 0, delta w by delta x is equal to del w by del x. Along y axis x is equal to 0, so z is equal to iy. Therefore delta z is equal to I delta y. dw by dz is equal to limit delta z tends to 0, delta w by delta z is equal to limit delta y tends to 0, delta w by I delta y, because delta z is equal to I delta y. This is equal to minus of minus delta w by delta y. These are two equations. Equating equations 1 and 2, we have del w by del x is equal to minus I del w by del y, implies that del u by del x plus I del v by del x, because w is equal to u plus iv, implies that del u by del x plus I del v by del x is equal to minus of I del u by del y plus del v by del x. Separating real and imaginary parts, we have del u by del x is equal to this is y. This is not x, this is y. Implies that del u by del x is equal to del b by del y, del u by del y is equal to minus of del b by del x. These equations are known as Cauchy-Riemann equations. Sufficient condition for fz to be analytic. This is theorem 2. The function w is equal to fz is equal to u plus iv is analytic in a domain D if u, v are differentiable in D and ux is equal to vy, uy is equal to minus of vx, that is f satisfies CR conditions. The partial derivatives ux, uy, vx, vy all are continuous in D. If any function satisfies these two conditions, then this function must be analytic. Proof. Let w is equal to fz is equal to u plus iv is equal to uxy plus ivxy is equal to f of xy be such that del u by del x is equal to del v by del y, del u by del y is equal to minus of del v by del x, or ux is equal to vy, uy is equal to minus of vx. Also let these derivatives be continuous. Let the increments delta z, delta u, delta v, delta w of z, u, v, w correspond to the increments delta x, delta y of x and y. Continuity of ux implies that delta u is equal to ux delta x plus uy delta y plus alpha delta x plus beta delta y. Similarly, delta v is equal to vx delta x plus vy delta y plus alpha 1 delta x plus beta 1 delta y, where alpha, beta, alpha 1, beta 1 all tend to 0. As delta x tends to 0, delta y tends to 0. Now delta w by delta z is equal to delta u plus I delta v by delta x plus I delta y. This is equation number 2. Delta u plus I delta v is equal to delta x ux plus I vx plus delta y into uy plus I vy plus alpha plus I alpha 1 delta x plus beta plus I beta 1 into delta y is equal to delta x ux plus I vx plus I delta y minus I uy plus vy plus alpha dash delta x plus beta dash delta y, where alpha is equal to alpha plus I alpha 1 and beta dash is equal to beta plus I beta 1. Using equation number 1, we have delta u plus I delta v is equal to ux plus I vx into delta x plus I delta y plus alpha dash delta x plus beta dash delta y. Dividing both sides by delta x plus I delta y and using equation number 2, we get delta w by delta z is equal to delta u plus I delta v by delta x plus I delta y is equal to ux plus I vx plus alpha dash delta x by delta x plus I delta y plus beta dash delta y by delta x plus I delta y. Implies that modulus of delta w by delta z minus ux plus I vx is equal to alpha dash delta x by delta z plus beta dash delta y by delta z less than or equal to modulus alpha dash into modulus delta x by delta z plus modulus beta dash modulus delta y by delta z implies that modulus of delta w by delta z minus ux plus ivx less than or equal to modulus alpha dash plus modulus beta dash, as modulus delta x modulus delta y always less than or equal to modulus of delta x plus I delta y. Therefore, modulus of delta w by delta z minus delta w by delta x less than or equal to modulus of alpha plus modulus of alpha 1 plus modulus of beta plus modulus of beta 1, as alpha dash is equal to alpha plus I alpha 1 and beta dash is equal to beta plus I beta 1. Now when delta z tends to 0, then right hand side of last equation tends to 0. That is, when delta z tends to 0, then this quantity tends to 0. Therefore, limit delta z tends to 0 delta w by delta z minus del w by del x is equal to 0, or dw by dz is equal to del w by del x is equal to ux plus I vx. But ux vx exist, hence dw by dz exists, so that w is analytic in D. Thank you very much for watching this video. Please don't forget to subscribe my channel. Please like, share and comment. Please press the bell icon to get notifications.